All right, I'm going to do number 8. We've got this ball thrown directly downwards with initial speed of this from a height of this. At what time interval does the ball strike the ground? So, constant acceleration, right? So I can jump to my equation sheet and realize that x equals x naught plus v initial naught x delta t or t plus 1/2 ax t squared for my equation sheet. And I'm going to set, where do you guys want to put 0? At the top or the bottom? Bottom, okay. Which way do you want to call positive? Down, down. Okay, down. We'll call down positive since you guys wanted that. Okay, so. Sure, positive can be sideways too. So we're calling this at 0 meters. We're calling this direction as positive. So that means that this is at negative 29.4 meters. So we're going to end up at 0 meters. We're going to start at negative 29.4 meters plus positive, because it's downwards, 7.85 meters per second. T, we'll assume that it starts at T0 plus 1/2 downwards, so 9.80 meters per second squared is its acceleration. Since it's in free fall, T squared. And grab my handy dandy calculator. Oh, I gotta grab my updated version. 0 for what? Good. Yep. It does. Now I can, the thing that, well, not factor out, but I can use my calculator to my advantage here, and use the solver in the math. Solve it. Even my old clunky 84. I gotta get my simulator updated, I think. So I'm gonna go to math. How many people have the 84? Who's got higher than the 84? You can. Well, I mean, like the one that I don't have the 89. I have the 84 plus. Well, I normally do. Okay. You have the 83? Okay, that'll work. I just like the solver better on the 84 plus, but it's just easier to use because they made it smarter. So I just went to math, solver, and I hit the math button, and then I arrowed up one because solver's on the bottom. Yeah, so on the 84 plus, you get 2 boxes. So you put one side of the equation in one box, and the other side of the equation in the other box. On the 84 and 83, it wasn't as sophisticated. You have to have the equation equal to 0 to do it. So all it means is you have to do one more algebra step than on the 84 plus. I've got to see. I think I have the newer simulator, but we'll see. So I'm going to put in this equation. I'm going to put in negative equals negative 29.4. Make sure you use the negative, not the positive. Plus, not the subtraction. Plus 7.85. And then I'm going to use my x key for my variable. Plus 0.5 times 9.8. And then x I'll use again, and I'll square it. So I've just put in my equation, right? I hit enter on it. I need to bound it. I'm only caring about real answers. So on my bound, I'm going to put in 0, comma, 1 e to the 99th. And I'm going to put in a guess of 1 just to start it off. And then I do alpha, enter, which gives me solve. And my answer comes out to be that t is 1.78 seconds. Let me see if that is correct. I'm hoping it is. Let's see. 1.78. On Tuesday afternoon. Yay! All right, let's do number 5. This Super Ball traveling at this, bounce off brick wall and rebounds to this. A high-speed camera records the event. The ball is connected to the wall for this, with magnitude of the average acceleration of the ball during this time interval. I bet you they reuse this problem with momentum and impulse. Bet you they do. Because that's, why else would they give you the inertia of it? Unless you were worried about the impulse on it. And I think they insult you a little bit by reminding you that 1 millisecond is 10 to the minus 3 seconds. I wouldn't take that from them. Alrighty. So, I am going to use, let's see, I know the initial velocity, I know the rebound velocity, I know the time of contact. So, I'm looking, again, it's going to be a constant acceleration because we can approximate the average acceleration is another way of saying, hey, consider the acceleration constant, right? Non-time dependent. So I should use that x equals x naught plus v naught xt plus 1/2 ax t squared as my idea again. I've got the wall, I've got the ball, it comes in and it hits and it comes back out. Again, which way do you guys want to call positive? Into the wall or out of the wall? Into the wall. Good, we'll call that positive. Actually, we're not going to use this because we don't know about distance. Excuse me on that one. Wow. We're going to use that V final equals V naught plus AT. And our V final is going to be negative 20 meters per second. Our V initial is going to be 27.0 meters per second. Our A, we don't know. Do we expect a positive or negative value for our A in this case? Well, if our velocity is going from positive to negative, what do you think? Negative. But what do you think we should put as our answer? Positive, because they asked here for the magnitude. They just want to know how big it is, not what direction. So, and then my time is 5 times 10 to the minus 3 seconds. Solve for A. And I'm going to get a negative number, and then I'm going to use that. So I'm going to do, let's see, minus 47 divided by 5. And I get vectorially, I should probably throw vector symbols on it just to make myself happy. Vectorially, I get negative 9,400 meters per second squared. So my magnitude is just 94. 100 meters per second squared. Fingers crossed. Yeah, you were just asking which one goes where. Except for making sure we get the directionality correct, it really doesn't matter. Because think about if we looked at it this way. We looked at the definition of acceleration as the change in velocity over the change in time. And we said, okay, well, the change in my velocity, it's going from 27 one way to 20 the other way. So that's a change of 47 meters per second. And the change in my time is 5 times 10 to the minus 3 seconds. So just by using that definition of acceleration, Ed, does that make sense also? Yeah, but does this make sense how to do it in your head even?